Morning to all. During the last class, we are discussing about atoms and molecules. We learned that a great Indian philosopher, Maharshi discovered that on dividing a matter, at last we reach a stage or we get a particle that cannot be divided further. This individual particle is called Paramanu as the language of Maharshi Kanada. Later, another Indian philosopher, namely Pakuda Katyayana, also supported his statement that the particles are not exist in free state in a single form, they are found in the combined state. Later, Democritus and Leucippus called these induced particles as atoms. Yet, they cannot give a clear explanation to these principles. Why? Their explanations were based only philosophical considerations, no experimental background. Later, the scientist named Anthony L. Lavoisier laid the foundation for the chemical science. You have to remember the name of scientist, Anthony L. Lavoisier, who is the scientist. He laid the foundation for chemical science. How he laid the foundation for chemical science? He put forward two great laws to the chemistry of world. The scientist, namely Anthony L. Lavoisier, put forward two great laws to the world of science. What are these laws? The law of conservation of mass, as well as the law of constant proportions. The law of conservation of mass states that mass can be neither created nor destroyed. They can only change it from one form to the other form. They cannot be created, they cannot be destroyed. Law of constant proportion also states that in a chemical substance, the elements are found or formed in a definite proportions. In a chemical substance, the elements are found in a definite proportions. These two laws, by put forward these two laws, namely the law of conservation of mass and law of constant proportions, the Anthony Lavoisier put forward the foundation, laid the foundation for the chemical science. Yet, they cannot give an appropriate explanation to these laws. Then came the scientist John Dalton. It is a John Dalton who gave an appropriate explanation for these two laws. How we give an appropriate explanation? John Dalton, by doing experimental work, he put forward the atom theory. The atom theory was put forward by a scientist named John Dalton. It is also known as Dalton's atomic theory. Let us see what are the important postulates of John Dalton's atomic theory. The first postulate was that all the substances are made up of small particles, namely atoms. All the substances are made up of small particles, namely atoms. Second postulate was these atoms or these small particles are indivisible, that cannot be further divided again. The third postulate was all the atoms in a substance are identical in properties and size and shape. All the atoms in a substance are identical. And the fourth postulate was, in a substance, the different substance, the properties are different. The fourth next postulate was that in a compound, the elements are combined in the ratio of small whole numbers, like 1, 2, 3. The elements are combined in the form of the ratio of small whole numbers. These substances combined in a fixed, definite proportions. These are the 6 postulates of Dalton's atomic theory. Dalton's atomic theory was made a great change in the world of science, the world of chemistry. John Dalton's atomic theory and its important postulates. So you have to the introduction page of the page. You have to remember the names of these scientists and their contributions. Today we are going to study what is an atom. What is an atom? What are the things you know about atom? The first thing you have to know is that atom is very, very small. Atom is very, very small, very, very tiny particle. It is too small to see with our naked eye or with a powerful microscope. It is very, very small. Then, what is the next thing? The atoms are indivisible. It cannot be the small indivisible particle of a substance. The small indivisible particle of a substance. We can't imagine. It is too small. That means we can't imagine at least the size of the atom. It is beyond our imaginary, and that is, it is too small. How the size of the atomic radius or the radius of an atom can be measured? The radius of the atom can be measured by using the unit named nanometer. The size of the atom can be measured by the unit named nanometer. 1 nanometer is equal to 1 by 10 raised to 9 meters. 1 nanometer is equal to 1 by 10 raised to 9 meters or 10 raised to 9 meters. That means, therefore, we can by using the modern techniques, the scientists measure the size of the atomic radius of the different substances. Like hydrogen, the atomic radius of hydrogen was 10 raised to minus 10 meter. The atomic radius of a water molecule is equal to 10 raised to minus 9 meter. The atomic radius of hemoglobin 10 raised to minus 8. The atomic radius of sanguine 10 raised to minus 4. Thus, atomic radius of small ant 10 raised to minus 2. The watermelon 10 raised to minus 1. You can see that how small the unit is. This is to the atomic radius of the substance shows how small the size of the radius or how the radius changes. Then these are the next. By using this nanometer, you can measure the different size of the atom. Then what is the importance of this atom? He says that is too small. Then the size is very insignificant to the world. The atoms are too small. We can't see it with the naked eye or with the powerful microscope. Then what is the importance? Then or why we care more importance in these atoms? They are the building blocks of all the substance, the entire world. They are the building blocks of all the substance, the entire world. So we must care about them. They are the building blocks. What do you mean by building blocks? Atoms are the building blocks. What do you mean by the building blocks? How this school building is constructed? With which material this school building is constructed? We use cement blocks. You see the ant hills. But do you know what is ant hill? The home of ants are built up using sand. We can see different sizes and shapes of ant hills in our surroundings. These ant hills are built up of small sandy grains. Therefore, the sand grains are the building blocks of ant hill. The sand grains are the building blocks of ant hills. With which material your houses are made up of? Your houses are made up of either bricks or cement blocks. So they are the building blocks. So life with how the material iron is made up of, or how the material element carbon is made up of. Iron is made up of iron atoms. Carbon is made up of carbon atoms. Similarly, any substance in the world, the chalk with which it is made up of, it's made up of calcium sulfate molecules or calcium, sulfur and oxygen. So, atoms, in short, all the substance, the entire world is made up of small atoms. They are the building blocks of all the materials in the entire world. So, we must care about them. We can't ignore the importance of the atoms. We can't ignore the importance of the atoms. You know that nowadays the pandemic COVID-19 spread all over the world. Which spread the COVID-19? The coronavirus. The coronavirus is spreading the disease, the pandemic disease all over the world. Though it is the coronavirus is very, very small, we can't see it. Then why we care about it? It affects. Though the coronavirus though it is very, very small, we can't ignore the existence of coronavirus. Why? It affects. The coronavirus affects the whole world. The world were shivering due to the influence of this coronavirus. So, never we can ignore, though it is very, very small, we can't see it, we can't ignore the importance. The unseen coronavirus can have the capacity to vibrate to the whole world, like the atoms. Though it is very, very small, its importance is very important in our world. We can't ignore its nature, its properties, its control, with all the substance in the universe is made up of the atoms. Then we can come to so what is an atom? It is the small indivisible particle of a substance. The small indivisible, but indivisible cannot be divided. The small indivisible particle of a substance is known as an atom. It is the building block of all the substance in the world. Its radius its size can be measured by using the unit named nanometer. 1 nanometer is equal to 10 raised to minus 1 meter. Let us pass on the symbols. What do you mean symbols? Symbols represents what is it? Symbol is the short form of the chemical name of the element. How many elements are at present? At present, there are 118 elements. 18 elements. Who approve the 118 elements? In chemistry, there is an international organization, namely IUPAC. In chemistry, there is an international organization. What is the name of the international organization? IUPAC. What is its full form? International Union for Pure and Applied Chemistry. This organization is a world organization. This organization gives the approval of the elements, compounds, and their names. At present, IUPAC approved the existence of 118 elements. First, you have to study, that full form. I, International, U, Union, P, Pure, A, Applied, C, Chemistry. International Union for Pure and Applied Chemistry. This organization give approval to the names and symbols of all the elements. In the earlier stage, the symbols represent a definite quantity of the element. A definite quantity. You know who put for the footsteps? Or who use the symbols at first? The symbols was put forward the scientist, namely our Indian scientist John Dalton. John Dalton is the first scientist who put symbols instead of their names. In John Dalton introduced symbols and it represents a definite quantity of the element. So you have to remember what's an atom, it's a building block, the symbol and a UPSC. John Dalton is the first scientist who first used symbols. In John Dalton's view, hydrogen represents his symbol is like oxygen, symbol is like and carbon. According to John Dalton, the symbol of phosphorus and the symbol of sulfur and the symbol of iron and the symbol of gold symbol of lead. These are the symbols given to elements by the scientist namely John Dalton. It represents a definite quantity of the elements. Later, the scientist named Berzelius is known as the Berzelius who put forward the language of chemistry, like Malayalam, English, and Hindi. Berzelius says that in chemistry there is a special language which is known as language of chemistry. Language of chemistry. The chemical reactions and their changes can be represented by easily and a short manner by using the language of chemistry. The language of chemistry was put forward by the scientist named Berzelius. So we have to remember to these. John Dalton first used the symbols to the elements. Later, Berzelius put forward the language of chemistry in explaining the reactions, atoms and molecules, etc. Then, how the names of the elements originate. For example, the name of copper. It was first mined from a place named Cyprus. So copper is obtained from Cyprus, it is called copper. Similarly, other elements, gold is named aurum. It means yellow in color. So, the names of elements, the origin of the names of the elements was from their places, their color. We can point out so many examples. In your test or in your periodic table, there are 118 elements. Out of 118 elements, there were the names originated from the names of the country, either from names of the country, or there are some elements, their names are one, Americum, their symbol is AM. Californium represents California. Germanium represents Germany. Polonium represents Poland. So, at present, for the modern science, the names originated from the names of the country. Then, names of the scientists. There are some elements which were used for the remembrance of some scientists. For example, the element named Mendelevium. Mendelevium represents the scientist Mendeleev, who is known as the father of beauty. Fermium. Einsteinium, the scientist named remembering scientist Einstein. Curium, Fermium, Mendelevium, etc. They are their names originated from their scientific scientists. Some countries, scientists, some Greek gods. The names of some elements are given to either Greek gods, like Prometheus. Prometheus is name of the element which remembers the Greek god Prometheus. Then color. We can say that gold, the color is aurum, it represents yellow. Chlorine, chlorus, green. Some elements were the planets. Neptunium, plutonium represent planets. So, out of 118 elements, the modern scientists or the UPSC gives then either names of the scientists, names of the country, names of the color, names of the Greek gods, etc. Then, how now at present, what's our point of view? The symbols. The symbols represent one atom of a element. It is a short form of the chemical name of either the first letter of the chemical name, either in English or in Latin or in Greek, etc. For example, the name of hydrogen is symbol H. You can remember some of the names or the symbols of the elements. First of all, you have to remember that there are 118 elements. 118 elements. The first letter of the name of the element. We don't bother about the name, either English or Latin, you can study later. The first letter of the element must be always be capital letter. The first letter of the name is always capital letter. For example, hydrogen is said simply H, not H, it is wrong. The first letter of carbon, C, not C. So, like the first letter of nitrogen, N, not N. So, you are while writing the symbol of the elements, two things you must always remember. What are the first thing I said to you? The first letter must be always capital. Then there is some cases, there are two letters must be written. in some cases. However, when there are some cases, the name of the element starts with the same letter. If the name of two or more elements starts with the same letter, we can identify, for example, the name of carbon, C, calcium C, chlorine C. Then how we can identify? Carbon is simply C. Then calcium we have to write Ca. Chlorine we have to write Cl. The second thing you have to remember always is what? If we use two letters, the symbol of an element, the second letter must always be a small letter. Never use Ca. Calcium is never used. Or never use Cl. It is wrong. Always use. So, by writing the symbol of these elements, you have to remember these two things. What are the two things? The first letter must always be capital letter. If we use two letters, the second letter must always be small. I said to you that when there is a chance to write two letters, the name of some elements starts from the same letter. It may be also way say that, for example, nitrogen. The symbol of nitrogen is N. What is the symbol of sodium? Na. What is the symbol of niobium? Nb. So, the three elements, nitrogen, sodium and niobium. The three elements starts their name with the same letter N. So, in order to distinguish between nitrogen and sodium or nitrogen and niobium, we have to use the second letter also. Then there is another question. The name of sodium is sodium. The symbol of sodium is what is the symbol of sodium? Either S? No, S represents sulfur. But then what is the symbol of sodium? The symbol of sodium is Na. How the symbol of sodium comes from Na? I said to you earlier, by naming, we use the first letter of their name either in English or in Greek or in Latin. The Latin name of sodium is natrium. The Latin name of sodium is natrium. So the symbol we do. Similarly, the symbol of what is the symbol of potassium? The symbol of potassium again, it comes from the name kalium. The Latin name of potassium is kalium, so its symbol is kalium. Similarly, the symbol of what is the symbol of iron? The symbol of iron is Fe. Where does it come from? The Latin name is ferrum. The Latin name of iron is ferrum. So its symbol is Fe. Similarly, the symbol of copper, not Co. Co represents the element copper. Cu represents cuprum. The Latin name of copper is cuprum. So it's similarly, what is the symbol of gold? Not G. Au. The Latin name of gold is aurum. Au. So, by selecting the names of or the symbol of the elements, we have to use the first letter or first two letters of the elements or the names of the elements. First of all, if you use two letters, the second letter must always be small letter. In your textbook, the symbols of some elements were given. You have to study it carefully. Then, if you study by using the symbols, we can the symbols represents one atom of the element. By using symbols, we can write the atoms, molecules, then molecular formula, then chemical equations. By using, before we all these activities, we use symbols. So first you have to learn, use it several times. Then you automatically learn the symbols by heart. By using the symbols several times, then you automatically learn the names by heart. For example, hydrogen H, hydrogen H. You don't you repeat the names several times. After some day you forget it. So you never want to repeat the names and symbols. By you look at the symbols and name and use it in several times, and then you automatically learn the names. If there is any comparison, you have to study the difference between them. For example, the important elements and their names are given in your textbook. You have to study it several times. For example, hydrogen H, hydrogen H, helium He. Then against the name lithium Li, beryllium Be, boron B, carbon C, nitrogen N, oxygen O, fluorine F, neon Ne. Then gives other elements: sodium Na, magnesium Mg, aluminium Al, silicon Si, chlorine Cl, sulfur S, etc. These almost all the elements. All these elements are almost all the elements present are very reactive and they are found in the combined state. Only those elements which is known as inert gases. That means helium, neon, argon, krypton, xenon, and radon. They are the inert gases. They are found in the free state. But all other elements are almost found in the combined form. So, after this, you have to study the names and symbols of our common elements which are familiar to you. The common elements which are familiar to you. For example, zinc is N, gold A, silver Ag. Then carbon C, calcium Ca. Then you have to use the common elements. Automatically you must remember the names and the symbol. You must always remember symbol is symbol represents an element. Symbol represents one atom of an element. One atom of an element. What is one atom? It is the smallest indivisible particle. Indivisible. Cannot be the particle of a substance. It is the building block of all the materials in the universe. Then came another thing. I already said to you that Anthony Lavoisier laid the foundation for chemical science. How he got the laid foundation? He put forward two important laws. Anthony Lavoisier put forward two important laws. What are they? Law of conservation of mass and law of chemical proportions, law of constant proportions. First, law of conservation of mass. Which mass? Atomic mass. Law of conservation of mass, atomic mass. How we can measure or calculate the atomic mass? We see that, or we learn that we can't see the atom. Then how we measure or how we weigh the mass of the atom? If we can see, we can measure it using a common balance. Or we can use different electronic methods, weighing machines for weighing the mass of different substance or weight of different substance. But the atom cannot be seen with our naked eye. Then how we can measure its weight? There comes the point how we can measure it. We can't measure it. We can't measure it. Then how we can calculate the ratio of different proportions of substance. Then there will the scientists take Another step is known as the relative atomic mass. Relative atomic masses. It is known as atomic mass unit. Atomic mass unit. AMU. What is the AMU? Atomic mass unit. Now it is also known as U, atomic mass unit. For comparing the masses of different atoms relating to one thing, that is the relative atomic mass. For comparing how is mass greater, or how multiple it is greater, or how multiple it is smaller than the base thing, than the standard thing, standard element, is known as a relative atomic mass. For this, the ancient scientific world, at first they took hydrogen as the basis for the relative atomic mass. Why they take hydrogen? They think that hydrogen is the smallest atom in the scientific world. That's okay, hydrogen is the smallest atom. Gasoline, one shell and small atom. Then they, after some experience, they cannot reach a success. They have failed on discovering the isotopes of different isotopes of hydrogen. They cannot explain it completely. Then they take another element, oxygen. Why they take oxygen? Oxygen combined with almost all elements, and they combine their whole numbers. Then they cannot also give a satisfied explanation for their inventions. That later the scientists discovered or take carbon-12 as the basis for measuring the basis of the atoms of the different elements. In 1961, carbon-12 is taken as the basis for measuring the masses of different atoms. Then what is the relative atomic mass unit? The relative atomic mass unit is a mass unit equal to exactly the mass of 1/12th mass of a carbon-12 atom. Do you know what I say? Do you understand what I say? Carbon-12 is taken as the basis for the measuring the masses of different elements, mass of the atoms of different elements. Carbon-12 is taken as the basis for measuring the different atomic masses of different elements. Do you know why they take carbon-12 as the basis? What is the reason behind it? They found that carbon-12 is the purest isotope which exists in large form of the universe. Carbon-12 is the purest isotope which exists in large quantity in the universe. It is the purest, carbon-12 is the purest isotope which exists in large quantity in the universe. So, carbon-12 is taken as the basis for measuring the relative atomic mass unit. Relative atomic mass unit of an atom. Then define atomic mass unit. Define atomic mass unit or define relative atomic mass unit. What is the relative atomic mass? It is a mass unit. It is a mass unit. This is a mass unit equal to the mass of 1/12 of a mass of carbon that is AMU atomic mass unit. Now it represents by the letter U is equal to 1 by 12 of 1 by 12 into mass of carbon 12. It is atomic mass unit. Then it's a difficult term. You have to understand it. Then you have to understand that for measuring the atomic masses of different substances, atomic masses of different elements, we have to take carbon 12 as the basis. Carbon 12 as the basis. What is the reason behind it selecting the carbon further and carbon 12? The carbon 12 is the purest isotope which exists large quantity in the universe, so it is selected. Then there are several elements which is less mass than carbon 12, and there is more elements which are greater than carbon 12. Then this atomic mass unit is a relative atomic mass unit in which we have been only comparing to the mass to that of carbon 12. Then, for example, if carbon 12 is taken as a basis for the comparison, then carbon 12 is, you think it is like a watermelon, and then it is cut into 12 pieces. Carbon 12 is taken as compared to as a watermelon. It's cut into 12 pieces. Then, while you are to these 12 pieces are compared to each piece is take, for example, hydrogen. When we taken as the mass of hydrogen in a common balance, the one piece is equal to a hydrogen mass. Then we take lithium. Then we get what's mass? It is lithium is 3, in the case of helium it is 4. Then in the case of oxygen, nitrogen, we need 14 pieces. In the case of oxygen, we need 16 pieces. In the case of sodium, we need 23 pieces. Magnesium, we need 24 pieces. So, you have to study the definition, and you don't bother about how you should calculate how to find out the atomic masses relating to carbon 12. There is no, you never need to find out the atomic masses. The atomic masses of 180 elements are always find out, and it is put as a chart in the periodic table. We have to only learn how they came to, or how they reach, or how they find out the atomic masses, which is only a relative number. It's only a relative number, not the actual number. It's only a relative number, and it is related to taken as the basis is carbon 2. So today we have to learn these points. What are the points? What is an atom? What is an atom? It is only a building block of everything. Then second thing, the size of the atom. How small or how big are the atoms? The third thing you have to study is the symbol of atoms. Symbol of atoms. The fourth thing, because the names of the elements. Names of the elements. The last thing you have to study is the relative atomic mass. The relative atomic mass. So we can let us wind up our class today. We can see the next class. Thank you all.